Hello, class. We are covering 5.7 here. This is going to be the first video. We're continuing with factoring. So take notes. 5.7, part 1, difference of two squares. And then in part 2, we'll address sum and difference of two cubes. Okay? All right. So difference of two squares. So difference, like sum means addition. Sum is related to is associated to with addition. Difference is associated with subtraction. Product is associated with multiplication, and quotient is associated with division. Okay. So when we say difference, we're talking about subtraction. And what are we subtracting? Two squares, so perfect squares. So if you don't know your perfect squares, then now would be a good time to list them. So your perfect squares are like 1 times 1, 2 times 2, which is 4, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9, 10 times 10. Anyone know what 11 times 11 is? Oh, I know you just said it in your room all by yourself. Okay, 121. Good. 12 times 12. 144. Okay, does anyone know 13 times 13? I believe it is 169. And then 14 times 14. Some math geniuses out there saying 196. 15 times 15. 225. Okay, we can keep going, but clearly I'm running out of space. All right, so those are your perfect squares. So when you have subtraction of two squares, then you can use this following formula. Okay, so to factor. So difference of two squares. So when you're subtracting uh, two squares, so for example, whatever a is, right? Actually, you know what? Let me use this symbol. It's funny looking x to represent that first term. So maybe it is x squared, or maybe it's 16x squared, right? Okay, so whatever that first term is. Okay, x squared minus y squared. So when you factor this, this is a very easy factor. Okay, so it turns out that if you have the difference of two squares, when you're subtracting two squares, then if you first identify what's being squared. So if you identify that, oh, it's x, whatever x is being squared, and y, whatever y is being squared, then your factors are going to be x plus y, x minus y. Okay? And that is pretty much it. Okay. If you notice here in the title, it says difference of two squares. And then over here for the second part, it says sum and difference of two cubes. Okay, so we don't do sum and difference of two squares because if you take the sum of two squares, it's actually not factorable under the real numbers. So if you have the sum, you just go ahead and say not factorable. You can, if you want to be super fancy, you can say not factorable with real numbers. You can factor it, but then you have to use imaginary numbers. Okay? All right, so this is something that you will need to definitely memorize. But I think after doing them so much, it just becomes a habit. Okay, so let's take a look at some examples and then we'll end this video. These are quick examples because it's a very easy factor. It's just x plus y, x minus y. And they're all going to be like that. X plus y, x minus y, x plus y, x minus y. Okay, so let's take a look. Factor. Let's say completely. Okay, so let's take a look at this one. X squared minus 36. Okay, so clearly both of these are squares, right? So first identify what's being squared here and what is being squared here. Okay, so over here, x is being squared. Here, 6 is being squared. Okay, so then those are going to be the terms that we use inside here. Okay, so identify what's being squared, what's being squared. So x is being squared and 6 is being squared. So then it's going to be x plus 6, x minus 6. Okay. Let's take a look at this one. Again, identify what is being squared, identify what is being squared. So here it's x and here it's 10. So we're going to get x plus 10, x minus 10. Are you hoping that I just give you a ton of perfect squares to factor on the test? Okay, let's take a look at this one. 4m squared minus 49. Okay, so let's identify what is being squared here. So here, 2m is being squared. And over here, 7 is being squared. So here, 2m is being squared. So we're going to get 2m plus 7 and 2m minus 7. Okay, so that's why it's important to first identify what is being squared here and here. Okay. All right. Suppose I have this 9w squared minus 25z squared. Okay, so let's identify what's being squared. So over here, 3w is being squared, and over here, 5z is being squared. So again, 3w and 5z. So we're going to get 3w plus 5z and 3w minus 5z. Okay. Let's take a look at this one. A squared b squared minus 16c squared. All right, let's identify. So here, A, B are being squared. And over here, 4c are being squared. So AB is being squared and 4c is being squared. So the other one's going to be AB minus 4c. Okay. And what about this one? If you're giving me an answer, there's no answer. This is not factorable. So this is the sum of two squares. This is not factorable with real numbers. Okay, so you can say not factorable, or we can say it's prime. Just like 7 is a prime number because we can't factor it other than 1 times 7, right? Same thing with this. This is prime. We can't factor this like these guys, except for 1 times x squared plus 4. Okay. And let's see if any of you guys can do this one. And I'll give you a few seconds to try it. Okay. So again, just identify what's being squared and see if you can do it. Okay. Go ahead and hit the pause button. Okay, so if you can identify what's being squared here and what's being squared here, then you should be able to still follow that same structure. Okay, so what's being squared here? A plus B. So then that's what we put down, A plus B. And then what's being squared over here? 3. So it's A plus B plus 3, and it's going to be A plus B minus 3. See how that works? All right, so that was just sort of a trick question to see if you guys would recognize the structure. If you were able to get that, then that's pretty good, quite impressive. Okay, so that is it for part 1. So in part 2, we are going to look at the sum and the difference of two cubes. Okay, so stay tuned.